Hello, this is Mr. Thompson again. We're going to be doing Chapter 3, problem number 73. This is on empirical and molecular formulas. This is on the homework that is due out of the second half of Chapter 3. The question is this: a compound has only sulfur and nitrogen and is 69.6% sulfur by mass, and the molar mass is 184 grams per mole. What are both the empirical and the molecular formulas for this compound? So the first step in this type of problem is to look at it and to say, all right, what am I given? You're given that there is 69.6% sulfur by mass, and because nitrogen is the only other element in this compound, we know that the remaining 30.4% nitrogen has got to be nitrogen because it is the only other remaining element. Once you get to this point, you've got the percentages by mass. This is the percentage by mass, and so really you could use any mass as a starting point, but because they're all percentages, it's easiest to just assume that you have 100 grams. So with these, assuming you have 100 grams of our compound, if you do have 100 grams, then you have 69.6 grams of sulfur, and we have 30.4 grams of nitrogen. Right? So once you have them both in their respective grams, now in some problems it may not be given directly like this, others it may be given like this one is, but once you have that, then you want to convert that into moles. And so if you remember our mole calculations, those are figured out by finding the molar mass of our respective compounds. And so we have here 69.6 grams of sulfur. To convert that into moles, we multiply that by 1 mole of sulfur over its molar mass, which in this case is 32 grams per 1 mole. So remember, 32 grams of sulfur, we have 1 mole, so therefore these units cancel, and we're left with 69.6 divided by 32, 2.175 moles of sulfur. Now, we want to do that in order to compare apples to apples, because molar mass of sulfur and the molar mass of nitrogen are going to be different, so we want to get them in a unit that we can compare directly. Same thing for nitrogen, except for in this case, in every 1 mole of nitrogen, there's going to be 14 grams of nitrogen. Now, the numbers are different. They're based right on the periodic table. I just grabbed those numbers off there. I am rounding a little bit right there, but in this problem, that's going to be okay. So we take those two things again, 30.4 divided by 14, and we get 2.174 moles of nitrogen. Now, at this point, hopefully they're like this problem, where if you look at this, you can tell right away that they're going to be in a 1-to-1 mole ratio. We have nearly the exact same amount of moles are present in 100 grams of this substance. So we know that our ratio is going to be, for every 1 mole of sulfur, we have 1 mole of nitrogen. Our ratio is 1-to-1. Now, other problems that the numbers do not equal each other at this point, what you would do is divide each of these different moles by the lowest number of moles listed. So if you had 2.175, 2.174, and a 1.05, you divide them all by 1.05. We don't have that in this case, so we know that our ratio is going to be 1-to-1. What does the ratio give us? The ratio then gives us what is the empirical formula. So the empirical formula here is going to be just Sn. 1 sulfur for every 1 nitrogen. Now, this tells us the lowest ratio that this compound contains of these elements. It does not tell us their actual numbers. There's a difference between the ratio of elements and the actual numbers of elements in a particular compound. They are sometimes the same, but not always. In this case, you can go from the empirical to the molecular by looking at the molar mass. So the second part, I'll flip over the page here in a second, is going to be to go to that next part. So our empirical is just 1-to-1, Sn. Our molecular, we know that the molar mass is 184 grams per mole, and we know that the empirical formula is just 1-to-1, Sn. So if we want to figure out how these things mesh together to get our exact molecular compound, we need to look at this and say, all right, what is my what's called empirical formula mass? All this is, it's a fancy word, but really it's just saying what is the molar mass of my empirical formula all by itself without being concerned about the molecular formula. So it's just going to be 32 plus 14, the molar masses of sulfur and nitrogen respectively. There's our 1-to-1 ratio, 1 sulfur, 1 nitrogen, and so you get a molar mass of 46 grams per mole. Now, we stop here and we can say that it is clear then that the empirical formula, 1-to-1, is not the same as the molecular formula, because we know the molar mass is 184 grams per mole. The problem told us that. We know that the empirical formula mass is 46, and so what we have to find is some ratio of elements. They're going to be 1-to-1, but some amount of elements that will get us a molar mass of 184. The easiest way to do this, because we know these things have to go into whole numbers, is to say that, well, how many times does my 46 grams go into my original molar mass? So take 184 and divide by 46. If you've done it correctly up to this point, you should get very nearly a whole number. As you look at this, you will see you will get the number 4. And so what does that mean? That means that there are 4 formula units. There's 4 of these things in the molecular formula. So you end up with S4N4. That is my molecular compound. Okay? You can double check and say, okay, does this still fit my empirical formula definition? It sure does. We still have a 1-to-1 ratio, S4N4. But if you look at the actual molecule and the way they're all arranged, you have 4 sulfurs bonded in a particular way to 4 nitrogens. And if you add up the molar mass of 4 sulfurs and 4 nitrogens, you can double check, you'll get 184 grams per mole. So with this, we get both pieces, the ratio and the molar mass. If you just have the ratio, there's any number of combinations. You could have S1N1, you could have S3N3, all the way down the line. If you just are given the molar mass of an unknown compound, there's lots of different things that can have the same molar mass. When you have both the empirical and the molar mass, you can figure out what is the actual molecular compound. Experimentally, this is how a lot of things have been determined in the past. If you have any questions, please ask them in class. Thanks.